2091 shortest path in binary matrix. So we are giving a binary matrix, so inside the values can only be 0 and 1 because it is a binary. So we are going to calculate the clear path. So the length of a clear path is the number of visited cells of this path. So for example, from 0 to 0, there are two visited cells. So the visited cells just means 0, so it is 2. So for example, there are 4 visited cells, so the length is 4. It is not 3, as you can see, because there are 4 zeros in this path, and it is the shortest. So we're gonna return 4. So for this example, because the top left corner, it is 1, not 0, so we're gonna return a -1. So this is a typical BFS problem. So the only difficult part is about there are only 8 directions. Yeah, and we can check it from here. All the weighted cells of paths are 0, so we're gonna check the 0, and all the adjacent cells of the path are 8 directionally connected. Yeah, so it means we need to check 8 directions, but not 4 directions. So that is the only difference for this BFS. Now let's just start coding. So for the BFS, we're gonna use the template for R and C row and column. So it will be the length of the grid and the length of the grid 0. Now let me prepare the directions, because there will be 8 directions. It's gonna be 0, 1, and 0, -1, and 1, 0, and -1, 0. So these are the 4 directions as normally the BFS, the top, bottom left, and right. Yeah. Now we are going to add another 4 directions. Basically, it is a diagonal. So we're gonna, from here, we're gonna prepare 1, 1, 1, -1, and -1, 1, and -1, and -1. So this is the 8 directions. Now we are going to prepare a weighted set. Yeah, so I'm gonna prepare a Q and weighted set. Q should be equal to the dq, and inside it's gonna be a tuple of 0, 0. It means the coordinates, and the distance is also 0. And the weighted set would be a set, but inside I'm gonna have a 0 and 0. It means this is the top left corner, but we need to check that. Yeah, we need to check the top left. So if grid RC, if grid 0, 0, it means if this is not equal to 0, so we're gonna return a -1. Otherwise, we're gonna prepare the Q and weighted. After that, we're gonna check this Q. So the RC and D is the distance. From the beginning, the distance is 0. Yeah. Now we are going to pop it out. So code should pop left. Yeah. And we're gonna check the directions for dr, dc in directions. And the row and column should be prepared to r plus dr and c plus dc. Now we are going to check the boundary. So the row should be more than or equal to 0, less than r, and column would be the similar, and less than column. And we need to check the row and column should not in weighted set, and the row and column should be 0. Yeah, row and column should be equal to 0. Then we can put it inside the weighted set. So the weighted set can end the row and column, and similarly Q should append the row and column with D plus 1. Yeah, because from the beginning we are giving a D as 0. So for example, this path is 1, but the result is 2. So this means from here we can check. So if R equal to R minus 1 and C equal to C minus 1, we need to return D plus 1. Because we are going to count how many zeros in the path. It's not about this distance, it is 1, but it is 2 because there are 2 zeros. If we didn't find it, we're gonna return -1. Yeah, now let me submit it to check if there's anything wrong with it. It seems okay. Now let me submit it. Yeah, as you can see, it works and it's pretty fast. And the time complexity, it is just m times n. M is the rows, number of rows, and n is the number of columns. So let's check the m and n. It is a very small number. That is why it is so fast. Yeah. Normally, while you analyze the problem, we can check that the directions is just 8 directions. It doesn't matter. But for the row and column, basically we need to go through all the possible row and columns to check it. It may be the maximum is R times C for the time complexity, and similarly for the space complexity, it is also R times C. Thank you for watching. See you next time.